Hello students, welcome back again to the lecture number 8. So we are continuing the exercise 7.1 and in this lecture we are going to solve another two last questions from that exercise, that is question number 7 and 8. So without wasting time, let's start the question number 7. Okay. So in the question number 7, as you can see, there is a figure and in this figure we have to understand some data from this statement. Okay, so let us understand it. So it is given AB is a line segment. So AB is a line segment and P is its midpoint. So it is given that if AB is a line segment and P is its midpoint, midpoint means this point, divide the line into two equal halves. It means this is equal to this. AP is equal to PB. Right? So what is given? It is given that AP is equal to PB. Understood? And D and E are points on the same side of AB. D and E are 2 points on the same side of AB. Means if AB is a line, then this is one side and this is another side. So both D and E lie on the same side. That means towards the uppermost direction of AB. Such that BAD means BAD, this angle is equal to ABE, this angle. So it is given that this angle is equal to this angle. Clear? And EPA, where is EPA? EPA. Oh, this is EPA. So this is equal to DPB, this. Understood? So these are the data that has been given from this statement. Now you have to show that the triangle DAP, which triangle? Triangle DAP. Which triangle? This triangle is congruent to the triangle EBP. EBP. Okay? So you have to first identify which two triangles. Okay? Don't confuse about which triangle and which triangle. First understand this question. Right? And have to prove AD is equal to BE. AD is equal to BE. Okay? So let us prove the first statement. So first write what is given in this question. It is given that BAD is equal to ABE and EPA is equal to DPB. Right? So to prove first statement, triangle DAP is congruent to the triangle EBP and AD is equal to B. So now we will start proving the first statement. Proof. First statement. So which two triangles we have to compare? Triangle DAP. So I find DAP. So between triangle DAP and triangle EBP and triangle EBP. Okay, now we have to prove whether these two triangles are congruent or they are not congruent. Okay, so let us find. See, in this triangle ADP, this angle means DAP is equal to, in this triangle, okay, which angle? This angle, because it is given. See the symbol, this angle is equal to this angle, it is given. So this angle is EBP. Okay, why? Because it is given. Understood? Now, in this triangle ADP, this side AP is equal to, in this triangle, this side PB. AP is a side of this triangle and PB is a side of this triangle. And it is given that AP is equal to PB. Why? Because P is the midpoint of AB. So we can write AP is equal to PB, and it is given. So the second statement is AP is equal to BP, not PB. It is BP. You have to write this BP. You have to write in proper order. Okay, AP, BP. Third condition. Okay, let's see. In this triangle ADP, okay, this is the angle P. This total is the angle P. Yes or no? Yes. So this angle is known as APD. Just understand it. APD. Just understand it. Okay. So can we write this total angle is equal to this small angle plus this angle? Can we write it? Yes, we can write it. So this angle means EPA. Understood? EPA plus this small angle EPD. Let me tell you again. In the triangle ADP, look at it carefully. The total angle can be written as this angle plus this small angle. Yes? So this angle plus this small angle. Understood? And if you consider this triangle, okay, this triangle, then this is the total angle P. This is the total angle EPB. So can we write EPB is equal to this angle, means which angle? BPD, or you can say DPB. DPB plus this small angle. Yes or no? EPD. Clear? Now see one thing. Since it is given that this side or this angle is equal to this angle, it means if it is 30 degree, then it should be 30 degree, because it is given EPA is equal to DPB. Okay, EPA is equal to DPB, it is given. So 30, it is also 30. Now, in order to find this total angle, we have to add this small angle. Similarly, in order to find this total angle, we have to add this small angle with this angle. So this is the common angle to this angle to this angle. Yes or no? Yes, this is the common angle, and these two are equal. And we know if two things are equal, and if we add the same thing with these two things, then the total will be equal. Right? See here, we know EPA is equal to DPB. Where? Here. So this is equal to this, and here we get this small angle as EPD. It is also EPD. If it is 30, it will be 30, and if we take the small angle to be 10, it will be 10. So it is 40, and it is 40. You have to reason it. You have to think it, right? So we get that for the triangle this APD, right? For the triangle APD, this angle is equal to, for the triangle EPB, this angle, right? So we can write APD. It is easy, don't be confused. It is very easy to understand, because this angle is equal to this angle. If we add the same common angle to both the angles, then they will be equal. So APD is equal to which angle? BPE. This stands for angle, this stands for side, this stands for angle. So by angle side angle congruency, this triangle is congruent to this triangle. Hence, by ASA congruency, okay, let it remove this triangle DAP is congruent to the triangle EBB. Did you understand it? So this triangle is congruent to this triangle. Clear? Now, coming to the second proof, how we can prove it. For this, you have to take this triangle ADP, or you can say DAP. Which triangle you can say, no problem. Now, this AD is a side in the triangle DAP. Right? Similarly, for the triangle this, which triangle? EBP. Now this is also a side. Yes or no? Yes. So BE is also a side, or you can say EB is also a side in the triangle EBP. But we know that these two triangles are congruent. These two triangles are congruent. And according to the exam 7.2, if two triangles are congruent, then their side must be equal. So you can write this side AD is equal to this side BE. Okay, so this side is equal to this side. Understood by axiom 7.2. Or you can write CP. Okay, this is the proof of one, and this is the proof of the second statement. Understood? And now coming to the question number 8, and the last question of this exercise. Okay, so it is given that in right angle triangle ABC, so ABC is a right angle triangle. Okay, we don't know which angle is 90 degree, but it is confirmed that ABC is a right angle triangle. Right angle at C, it is given that the right angle on the 90 degree is at C, it is given. That is why I have taken C as a 90 degree. M is the midpoint of hypotenuse AB. Tell me, which side is known as the hypotenuse? This diagonal portion is known as the hypotenuse. So it is given that M is the midpoint of hypotenuse AB. If AB is the hypotenuse, then you have to take a point M. You have to take a point M. Suppose this is M, and this M is the midpoint of AB. It means this side M is equal to this side BM. Clear? And C is joined to M. So it is given that this point C is joined to M. And produced. Produced means it has been directed in this direction. It has been produced. Okay, suppose it is this side is produced like this to a point D. Suppose this point is D. Okay, so that DM is equal to CM. So it is given DM this is equal to CM. Clear? Next, D is joined to B. So this D is joined to B. Okay, so this is the complete figure we have taken out from the statement. Now coming to the proof part. You have to prove 4 statements. So we will prove every statement individually. It will take a little bit time, don't worry. So let us first prove the first statement. Okay, proof of the first statement. Okay, so let us prove. So it is given. You have to find that the triangle AMC, this triangle is congruent to triangle BMD. We have to prove this. So for this you have to compare or between triangle AMC and triangle BMD. Among these two triangles, you can see in AMC this side means MC is equal to this side of the triangle BMD, this side MD. It is given, right? Second thing, you can see if this is a straight line DC, this is another straight line AB, right? Then these two angles are known as vertically opposite angles. So you can say that this angle and this angle are known as vertically opposite angle, and we know the vertical opposite angles are equal in measure. So you can write this angle DMB is equal to this angle AMC or CMA. You have to write CMA, not AMC, CMA. This is perfect. Okay, why it is perfect? Because we have started from D, so we have to start from C, right? Third condition is that this side of the triangle BMD is equal to this side of the triangle AMC. So you can write AM is equal to BM. Okay. So AM is equal to BM. So what we get? We get this side, this side, this angle, this side, this side, this angle. So by SAS congruency, these two triangles are congruent. Okay, by SAS congruency, triangle AMC is congruent to the triangle. Which triangle? BMD. Okay, it is proved. This is the first statement. Right? Proved 1. Okay. Now we have to conclude some result from this proof. What we can conclude? We know if two triangles are congruent, then their angles are equal, their sides are equal according to the axiom 7.2. Then can we write in this triangle BMD, this angle is equal to in this triangle AMC, this angle? Can you write it? Tell me, can you write it? Yes, we can write it because these are the corresponding angles of the two triangles. Understood? So you can write this angle is equal to this angle. Similarly, you can write this angle is equal to this angle. No problem at all. Okay? So you can write, implies, you can write BDM is equal to this angle. Okay? ACM. Or you can write this angle DBM is equal to this angle CAM. Why? By axiom 7.2. Why I have written it? I will tell you later. Because this result is used for the proof of second statement, for the proof of third statement, or for the proof of fourth statement. Okay, now it is clear. You have find the proof of the first statement and you get to conclusion from that statement. Okay, so now let us move to the second statement. Okay, what is that? DBC is a right angle. Right, so we will prove the second statement DBC. Which angle? DBC. Again I am telling you DBC. That means you have to prove that this angle is a right angle. How can we prove it? Let's see. It is not as difficult as you think. Okay, it is not as difficult as. Okay, see. We have find that BDM, this angle is equal to this angle. Can you tell me, if we forget about everything and only consider SC and DB, SC and DB, let me tell you, if we consider SC and DB as two lines, straight lines, and DC is the transversal line. Okay, like this. Suppose this is DB, this is AC, and we consider DC as a transversal line. What we find? We find this angle is equal to this angle, and these two angles are known as alternate interior angles. Okay. So we can write, since we have found this angle BDM is equal to this angle SCM, and these are alternate interior. Okay. Then remind the theorem. If there are two lines and there is a transversal line, and if the pair of alternate interior angles are equal, then these two lines will be parallel. Okay. So now you can write that this line and this line, it means this line and this line will be parallel. So implies DB is parallel to AC. Okay. I think it is theorem number 7.4. Okay, sorry, 6.4. Might be 6.3. I didn't get it, but it may be theorem 6.4. Now it is clear that this line and this line is parallel. It is clear now? Next, target is to find this angle DBC. DBC is right angle. How? See, if these two angles, so these two lines are parallel, then can we write this angle and this angle are co-interior? See this figure. We have taken DBAC. I told you, if DB and AC are two parallel lines and BC, this BC is a transversal line, then this and this are known as co-interior angles. Okay, so we have find DB parallel to AC, and if BC is transversal, then this angle means this angle and this angle means this angle are co-interior. Okay, so let us write this. Since there is no space, I have to erase it. You can take the screenshot, right? So this angle means ACB and this angle DBC are co-interior. This is, I think, theorem number 6.5. Maybe it is 6.5. And we know the sum of two co-interior angle is equal to 180 degree. And we know ACB plus DBC is equal to 180 degree. Isn't it? Right? But it is given that this C is what? This C is what? Is right angle. So this angle is 90 degree. So 90 plus DBC is equal to 180 degree. And DBC is equal to 9, moves to the right hand side, it will be 180 degree minus 90 degree is equal to 90 degree. Hence we proved that DBC is 90 degree, it means DBC is a right angle. If it is 90, then no doubt you can say yes, it is also 90, because 90% is 180 degree because they are co-interior angles. Okay. So we have proved the first two statement, that is the triangle AMC is congruent to the triangle BMD. So this triangle and this triangle are congruent. Now we have get some conclusion, get some data from this congruency. What are the data? Let's see. Since triangle AMC is congruent to the triangle BMD. Now, if any two triangles are congruent, then according to the exam 7.2, we know that their corresponding sides must be equal. Okay, so here we can write that this side BD of the triangle BMD is equal to the side CA of the triangle AMC because they are the corresponding parts of congruent triangle. So BD is equal to CA. We can write it. BD is equal to CA. We can write it. Understood? So this conclusion we draw from the, or we have taken from the first statement. Right? Now, from the second statement we have known the triangle, that angle DBC, this angle is a right angle. It means this angle is 90 degree. Okay, so we can write that DBC is 90 degree. We have got it from the second statement. Right? So coming to the third statement. This third statement can be proved by using the conclusion from the other two statements. Okay, so let us prove it. So proof of the third statement. So the third statement is triangle DBC, this triangle is congruent to ACB, this triangle. Okay, this triangle is congruent to this triangle. So let us prove. Now compare these two triangles between triangle DBC and triangle ACB. Okay, so let's see first thing. Since we have proved that this side DB is equal to AC, DB is equal to AC. Why? Because we have proved it. BD is equal to CA. This distance is equal to this distance. Why? Because these two are congruent triangle and these are the corresponding parts. So we can write the first statement that BD is equal to CA. Why? Since this two triangle BMD is congruent to the triangle CMA or AMC, right? Second thing, see, if we consider this as a triangle, then this angle is 90 degrees. So B angle is 90 degrees. Similarly, if we consider this triangle SCB, then this angle C angle is also 90 degrees. So this angle is equal to this angle. So angle B is equal to angle C. And then the third statement is that if we consider this triangle, then this BC is a side of the triangle DBC. Understood? Similarly, if we consider this triangle ABC, then this BC is also a side for the triangle ABC. So what we find? We find that BC is the common side to both the triangle. So we can write BC is equal to BC common side. So this stands for side, this stands for angle, this stands for S or side. So by SAS congruency, this triangle DBC is congruent to the triangle BSC. So we can write hence triangle DBC is congruent to the triangle ACB by SAS congruency. Hence it is the proof of the third statement. Okay, now it is proved. We have proved this statement, right? Next is this statement. We have to prove this statement. As I have told you, in order to prove any exceeding statement, you need the conclusion of the previous statement. So we have to prove this by using some data from this statement. So which data should be taken out from this condition, this case, that the triangle DBC is congruent to the triangle SCB? Which data should we take? See, since these two triangles are congruent, right? Then if we consider DBC as a triangle, then this DC is a side of which triangle? Triangle DBC. Okay. Similarly, if we consider this triangle SCB, then AB, okay, is a side of which triangle? Of triangle SCB. Understood? But what we have proved? We have proved that triangle DBC is congruent to the triangle SCB. So we know if any two triangles are congruent, then their corresponding sides must be equal. And these are the two corresponding sides. So we can write that DC is equal to AB due to axiom 7.2. This is clear, na? Next. Okay, then DC can be written as DM plus MC or CM. DM plus CM, because M is a point in between DC. So you can write DM plus CM is equal to AB. No problem. Now, since what we have found or what it has been given, it has been given that DM is equal to CM. DM is equal to CM. So in the place of DM we can substitute CM. So let's substitute it. CM plus CM is equal to AB. 2CM is equal to AB. CM is equal to AB by 2. 2 moves to the right hand side, it will be divided. So CM is equal to AB by 2 or CM is equal to half AB. Now we have proved this and we need to prove this statement. Hence this is the proof of the fourth statement. Understood how we proved it? Since this triangle is congruent to this triangle, so this side is equal to this side, this is equal to AB. Now this can be written as DM plus CM is equal to AB. Since DM is equal to CM, so in the place of DM we can substitute CM. CM plus CM is 2CM is equal to AB and CM is equal to AB of half or half AB. Okay.